So the previous chapter was discrete random variables. Okay, if you have any question from the previous chapter, you may go ahead now. Okay, in case there is no question, let me move on to continuous random variables. Let me brief what we did in discrete random variable case, and then I will match one-to-one properties of discrete and continuous. So we started chapter 3 with the general definition of random variable. And we said usually we denote it by x. And then we said that there are two categorizations. One of them is called discrete, and one is called continuous. Chapter 3 was all about discrete random variables, and what we did in discrete random variable, we said that x is called a discrete random variable where the domain of x is like it is like a1 plus 1. Let's call a better. a plus 1, a plus 2, all the way up to b. And sometimes a was 0, b was a finite number, sometimes b was a finite number, b was infinity, sometimes a was 0, b was infinity, and so on. On this domain, we said that the probability mass function.
Doctor?
Yes.
Did you share the screen? Because I cannot see it.
You cannot see it? Can anyone else see it?
I can see it.
Yes, I can.
I can see it.
The one who cannot see it, I would like you to leave the session and join the teams again. So you said x follows this function f of x, and you called this function as probability mass function. And regarding this function, you said it satisfies two conditions, and those two conditions were what? That this is a non-negative function, and this is a function whose sum is 1. over the domain of X from A to B. And using this probability mass function, you talked about some properties of discrete random variables, and those properties or what you found mean of X. You said this is summation X times f of X. You found variance of X. This is, you said, summation X squared times f of X minus mu square. You found standard deviation, which I'm not going to write, it's just the square root. You found capital F of X. You said this is summation of small f of X from A to a specific value X. Let me use a different notation for this one. Capital F of, I would say, f of C from A to a specific value C. And I think this was it. This was all you did. And then you went specific. Then you went specific with special distributions like discrete uniform distribution. You talked about the properties of discrete uniform distribution. Then you talked about binomial, properties of binomial, negative binomial, properties of negative binomial, hypergeometric, properties of hypergeometric, and Poisson, along with the properties of Poisson distribution. We are going to follow exactly the same map in continuous random variable. Now, when you talk about continuous random variable, the first thing that comes is the domain. And when you talk about the domain of a continuous random variable, the domain of a continuous random variable is always continuous. So the domain of continuous random variable is written like A less than X less than B. And inside A and B, there are infinite number of values. Whether how close these numbers are, still there will be infinite number of values between A and B. Even if A and B is like the domain is from 0 to 1, between 0 to 1, there are infinite number of values. Now later I will tell you that putting equal sign in continuous random variable or not putting an equal sign with these less than equalities doesn't matter. For continuous random variable, it doesn't matter. For discrete, it does matter. Then you will define the probability density function. You will call this function a probability density function for a continuous random variable. And this probability density function will again satisfy two conditions. One of them will be this probability density function will be non-negative, and now for the continuous you will integrate. You will integrate it from A to B. The overall integral over the whole domain, that should be equal to 1. Once the probability density function satisfies these two conditions, then it can be used to find the following properties of random variable X. What properties? Same properties, the mean of X. That should be integral of X times f of X dx. The variance of X, that should be integral of X squared times f of X minus mu square. And the distribution function of X at point C. That should be from A to a specific point C. Now in the discrete random variable, we only found this distribution function and we used it for the probabilities only. Here we will use this distribution function more comprehensively, not only for the probabilities, but also for finding the median, the percentiles, the quartiles. As we know, the general definition of f of c is what? Capital F of c is basically the probability of x less than equal to c. And same is true for discrete random variable. So this was one-to-one comparison of discrete and continuous random variables. Let us have an example. The question says that suppose you have a continuous random variable that has the PDF kx square, where k is an unknown constant. The first part says you find the value of k. Now you have to find the value of k using the properties of PDF. One of the properties of PDF is that if you integrate the PDF over the whole domain, that is for this question 0 to 1, you should get 1. So if I integrate this one, the integral of kx square, k, because the question says k is a constant, so the integration will be kx cubed divided by 3, and this is equal to 1. Which implies, sorry, yeah, from 0 to 1, which implies k over 3 into 1 cube minus 0 cube, this is equal to 1, which implies k is 3. That means your f of x is 3x squared. Now I will briefly talk about these equal signs here. Whether I put them or not put them, it doesn't matter. Why? I'm going to talk about that now. Now when I write the domain of x like this one, 0 less than x less than equal to 1, and I write it like this one, 0 less than equal to x less than equal to 1. What is the difference between the two? Can anyone tell me? Muhammad Faris.
The first one, 0 does not include. The second one, 0 include.
X equals 0 is the difference between the two, right?
Yes.
Now, in the first one, 0 is included. In the second one, 0 is not included. Now, including 0 or not including 0. Now the question is, does it make any difference in the continuous random variable? And my answer is no, and I will explain why now. It does make a difference in discrete random variable because the probability of x equals 0 can be something non-zero. X equals 0 can occur. There is a probability that x will be 0. But here I will show you that the probability of x equals 0 is basically 0. In the continuous random variable, the probability that x will be exactly equal to something will always be 0. Will always be 0, and I will show you this thing. Now, in this domain, I'll talk about the second one. In this domain, there is a one value that is x equals 0. How many total values of x are there? In the domain, how many total values of x are there? The values between 0 and 1.
Infinity.
Infinite. There are infinite values. So in your sample space, there are infinite values. And among those infinite values, there is one value that is x equals 0. So consider this as your event A. And you're trying to find the probability of this event A. That should be n of A divided by n of S. Now, in your sample space, there is one sample point that belongs to event A, that is x equals 0. And how many sample points are there in your sample space? There are infinite many of them. So the probability n of A, the number of sample points that belong to A, n of S, the total number of sample points in your space. So the probability of A is what? 1 over infinity, which is 0. And you can do this for any specific value of x. The probability that x is 0.5, that's also 0. The probability that x is 0.7, that is also 0. For continuous random variable, it is impossible for a random variable to take a specific value until it is observed. Until you round it. If you don't round it, there are infinite many decimal points that can happen. So it's almost 0, virtually 0. So including 0 in the domain or not including 0 in the domain, it doesn't matter for the continuous random variable. Same is true for the right side. Including 1 or not including 1, it doesn't matter. Find the mean of x. Let us try and find the mean of x. Muhammad Faris.
Yes, doctor, I have a question. If means the probability always equals 0.
The probability at a point is always 0. At a point.
Yes, okay, thank you.
In continuous random variable, the probability at the point is always 0. We always try to find the probability between the two values. We never find the probability at the point. If you get a question in exam to find the probability of a continuous random variable at a point without calculation, your answer should be 0.
Okay, thank you, clear.
In continuous random variables, we find less than probabilities, we find greater than probabilities, we find in between probabilities. The equal probability is always 0. Let us find the mean of x now. Using the expression, the mean of x is basically integral of 0 to 1, 3x square dx. And for the record, we will not give you complicated integrals in exam. The integrals will be very simple polynomial integrals. Very simple. So you don't need to worry about math 1 or 2. Now here the integral of x square is what? It's 3 times x cube over 3 from 0 to 1. Is it? Or we are making any? Oh, we missed one thing. The mean of x is integral 0 to 1 x times f of x dx. So that is basically integral 0 to 1 3x cubed dx. Now this integral is 3 times x to the power 4 over 4 from 0 to 1. So that will be 3 over 4, 1 to the power 4 minus 0 to the power 4. So this will be 3 over 4. That is the mean of x. Similarly, I can find the variance of x. That should be sigma square of x, which is integral x squared times f of x minus 3 over 4 whole square. So this is going to be 3x to the power 4 dx minus 9 over 16. And this is going to be 3x to the power 5 over 5 minus 9 over 16. And this is going to be 3 over 5 minus 9 over 16, which is what? 0.0375. Similarly, if I ask you to find the standard deviation, accordingly, the standard deviation of x will be the positive square root of 0.0375, and this is 0.194. Now let me look into the formula sheet and let me see what notation did I use for capital F of x. Let me change the notation here a little bit, because this C is C is looking odd here. Generally, we give notation, this C notation, to something constant. So let me change this C to f of what do I call it? Let's call it D. So let us try and find capital F of x, the distribution function. Find the CDF of x, that is capital F of x. Now to find capital F of x, you start with this. This is going to be integral, the lower limit, that is 0, all the way up to d. Now you integrate it, which is 3x cubed divided by 3 from 0 all the way up to d. So this is going to be 3 cancels out with 3. This is going to be d cubed. This is your capital CDF, capital F of x. You can write it in terms of x also. That means you can write it capital F of x equals x cubed. You can write it in terms of d, you can write it in terms of x, it doesn't matter. Now my question is, what does this capital F of D or capital F of X give you? This is the integration from 0 to a specific point. This is basically capital F of X is the probability of X less than equal to X. Let me call it D. Forget about this X. It's confusing. Capital F of D is the probability of X less than equal to D. So if I need the probability of X less than equal to any point, I can directly use capital F of D instead of using small f of X. I can also use that. I can also use this. So in continuous random variable, if I ask you a question about probability, you can use both of them, small f of X or capital F of X, both of them. Let me show you how. Find probability that X is less than half. I'm going to show you both ways to get these probabilities, and the second one will be easier. I can use simply f of X. So this probability less than half, this will be simply integral from 0 to half 3x square dx. And this is going to be the integral of 3x square is x cubed from 0 to half. So that is going to be half to the power 3. Who can tell me what is half to the power 3?
Uh, 0.125.
Half to the power of 3.
Yes.
0 point?
125.
125. This is the probability. Now I can find the same probability, this probability of X less than 0.5. I can also write it probability of X less than equal to 0.5. By definition, this is capital F of 0.5. Look at the definition of capital F. Capital F at a specific point is what? It's the less than equal to probability. So capital F of 0.5 can be written as probability of X less than equal to 0.5 and the vice versa. Probability of X less than equal to 0.5 can be written as capital F of 0.5. And we have capital F of D for this question. If you are interested in capital F at a specific point, it's that point to the power 3. So you can simply put 0.5 to the power 3 here without going into the integration. So if you have capital F of X available, it is always better to use the second one and avoid integration, because the second one is already an integrated version of the first one. That is, capital F of X is an integrated version of small f of X. If you use small f of X for finding the probability, you will have to integrate. If you use capital F of X for finding the probability, you don't have to integrate. Another question. Part 6. What if I ask you?
Sorry, doctor.
Yes.
Why I cannot use big of F in the first one, since the probability at specific value is equal to 0, so I can add equality without changing anything.
Let me see if I understood your question. You're trying to find probability of X equals 0.5. Is it?
No. What's the difference between probability of X less than or equal 0.5 and the probability of X less than 0.5?
No difference. They are same. I told you that there are two methods to find this probability.
Ah, okay.
You
Thank
can
you.
find this probability by two methods. Both
That's
of
clear.
them will give you same answer.
Yes, it's clear.
Any other question? Okay, let us practice another thing about this. Find the probability of x greater than 0.5, or let's say greater than 0.75. Now here, if I'm interested in using the probability density function, I can find it like probability of x greater than 0.75. That will be integral from 0.75 all the way up to 1, 3x squared dx. So that will be x cubed from 0.75 all the way up to 1. And this will be 1 cube minus 0.75 cube. And this will be, who can tell me, 1 cube minus 0.75 cube?
Yeah, 0.5781.
This is by using probability density function, PDF, small f of x. But what if I don't want to integrate? I can use capital F of x. How? Let me show you. Greater than 0.75, I can make use of the complement theorem. I will write it as 1 minus probability of x less than equal to 0.75. And then, now the second part, 1 minus, this can be written as capital F of 0.75. Because it's less than equal to. Less than equal to can be written as capital F of something. And this will be 1 minus capital F of 0.75, that will be 0.75 cube. According to this blue highlighted thing. Capital F of something is equal to something cube. For this specific question, for this probability density function. So I made use of that. I made use of this blue thing here. Capital F of anything is anything to the power 3. So that will be simply 0.5781 again. Same answer, but you avoided integration here. So we just saw we can find less than probability using both PDF and CDF. This is PDF. This is PDF. And this is CDF. We can find greater than probability using both PDF, CDF. Let's talk about in-between probability. What if I'm interested in in-between probability? 7, part 7. What if I'm interested in find probability of x between 0.5 and 0.75? Again, I can make use of probability density function, PDF. This probability will be simply the integration from 0.5 all the way up to 0.75 of 3x squared. And that will be x cubed from 0.5 all the way up to 0.75. And this is going to be 0.75 cube minus 0.5 cube, which is
0.296875.
2969.
Yes.
This is the traditional way of finding an in-between probability using the probability density function. Let me write it general here, that if these two conditions are satisfied, then the properties of x you can find these properties include the probability also. Let me write it here. To find the probability between A1 and A2, you just have to integrate the function between A1 and A2. This is what we did here. But we can solve this question without integrating also. We can avoid integration also. How? Let me explain. The probability of x between 0.5 and 0.75 can be written as x less than 0.75 minus x less than 0.5. Let me avoid the equal signs totally. I'm going to explain how, and I'm going to tell you what mistake you guys are going to make here. This is the domain of x from 0 all the way up to 1. And this is somehow the probability density function. It's a function. And you also said that if you integrate this function all the way from 0 to 1, the overall yellow area is 1. The area under this curve from 0 to 1 overall, that's actually the probability of x between 0 and 1. This overall area, yellow area, is 1. That is basically all the possible values of x and their probabilities. This yellow area, you said this is 1. Now in between 0 and 1, there is somewhere 0.5 here. And there is somewhere 0.75 here. And you are interested in the area between these two red lines. That is, you're interested in this area, the one I'm highlighting with the blue color, but it's becoming green because it's joining with yellow and it becomes green. You're interested in this area. That is the probability between 0.5 and 0.75. The area under the curve between 0.5 and 0.75, that is the probability of x between 0.5 and 0.75. This basically, let me write it. This area is probability of x between 0.5 and 0.75, the green highlighted area. This is where we are interested in, and this is what we did in the first way. We integrated from 0.5 to 0.75, this curve, this small f of x, and we got the green area, and we know the green area is 0.2969. What I'm trying to do here is I'm trying to avoid integration and see what I do now. Ultimately, I'm going to get to the green area, but in an indirect way. Now see what I do. I'm going to highlight something with the yellow color now. And I want you to tell me what is this something. What is this yellow highlighted area? Muhammad Ali.
X less than 0.75.
It's the probability of x less than 0.75, or I can say this is capital F of 0.75. The yellow area. Similarly, I'm going to highlight another, let's say blue area, and I want you to tell me what is this? Ali Abdul Rauf.
It is x less than 0.5, which is if
It is x
capital
less than
0.5.
0.5, which is capital F of 0.5. And I'm interested in the green area. Now look at the three diagrams. You have the yellow one. I'm going to get rid of this yellow one just for the sake of clarity. You have the yellow one, you have the light blue one, and you're interested in dark blue. How can you get it? Ali Abdul Rauf.
You subtract from the yellow the light blue.
You subtract light blue from the yellow one. So if you subtract the light blue from the yellow one, the remaining part will be in between. Or I can say in simple words, you have 0.5 here, you have 0.75 here. The yellow one is less than equal to 0.75. And the blue one is less than equal to 0.5. And you are interested in this one from 0.5 to 0.75. So I can say that the probability of this one is equal to this minus this. Or I can say the probability of x between 0.5 and 0.75. This is equal to probability of x less than 0.75 minus probability of x less than 0.5. And this is where I'm going to tell you where are you going to make the mistakes. The mistake most commonly I see is with these two signs. Both of them are less than. The most common mistake I will see is you will write this probability as probability of x less than 0.75 minus probability of x greater than 0.5. This is wrong. Both of them are less than. And now I'm going to write the general rule. And in general, the probability of A1 less than x less than A2 can be written as capital F of A2 minus capital F of A1. That's the general rule. For continuous random variable, Muhammad Shafiq.
Doctor, are there questions that I can't use integration because I feel more comfortable with integration than this?
With integration, you can go, but maybe I don't give you the small f of x. I give you capital F of x. So the first thing you'll need to do is you'll need to differentiate and get the small f of x back, and then you can integrate it again, which is a lot of work. You give me 10 minutes, I'll make you comfortable with capital F of x.
Okay.
Okay. So let us continue with our example. The probability of 0.5 less than x less than 0.75. This can be written as capital F of 0.75 minus capital F of 0.5. So that should be 0.75 cube minus 0.5 cube. And this is going to be exactly equal to 0.2969. Let us quickly solve another question. I have 15 minutes. Let me quickly solve another question. Let us say your f of x is 2e to the power minus 2x. I may ask you a question in exam. Is this a valid probability density function? Your answer should be yes or no. And how will you decide yes or no? Who can tell me? The question is this a valid probability density function? How can you answer this question? Muhammad Faris.
If the integral equal 1.
Two conditions. If this is a non-negative function and the integral should be 1. So if you put anything in this function where x is greater than 0, put positive values in the function. Put 0, put 0.001, put 99, put 999, put 1 million. Does this function go negative? 2 multiplied by e to the power minus something. This function will never go negative. So first condition, the function should be non-negative. The second condition, if you integrate the function over the whole domain, and the domain is from 0 to infinity. If you integrate this from 0 to infinity, you should get 1. And this is a valid probability density function. You will get 1 if you integrate this one. I'm not going to go and integrate it, but if you do it, you will get 1. Now here, before I go on and find the probabilities, I'm going to find capital F of x. And then later I will use that capital F of x to find the probabilities. I cannot integrate in every question. I don't want to integrate in every question. So capital F of x will be integral from 0 all the way up to x. 2e to the power minus 2x dx. And consider this x as a constant value. So what is the integral of e to the power minus 2x? It is e to the power minus 2x divided by minus 2. Yes? Is it? I'm not good in integration. Is it or is it not?
Multiply by minus 2.
Multiply or divide? I think in derivatives you
divide.
multiply.
Shouldn't.
In derivative you will multiply, I think, and in integral you will divide. Is it or is it not?
Yes, divide.
Yes.
Someone who got A plus in math 1 or 2, can anyone confirm? I did not get A plus in math 1 or 2, so I'm not sure.
I'm sorry, doctor, but shouldn't we increase the number to be minus 1?
Which minus 1?
And the first, I mean, the minus 2x should be minus 1.
No,
I
that's
think
the
correct.
question. That's the question.
No, our answer is correct here.
Which answer?
What you wrote.
Okay, it's correct. Thank you. So 2 cancels out with 2. And I have a minus. So I'm going to adjust the minus by flipping the domain. So e to the power minus 2x from x to 0. I got rid of the minus. And now I'll put the values. And I'll get what? E to the power minus 2 times 0 minus e to the power minus 2 times x. And I will get what? 1 minus e to the power minus 2x. This is my capital F of x. And this is basically probability of x less than equal to small x. And this is applicable for any value of x from 0 all the way up to infinity. Once you have this function, I'm repeating again and again, this function is more useful for finding the probabilities in case of continuous random variables. And in most of the questions in exam, we will directly give you this second function, not the first one. We'll give you the second function, capital F of x. So what if I ask you to find the probability of x equals 7? Who can answer?
Zero.
0. What if I ask you to find probability x less than equal to 7? Muhammad Ali. Muhammad Ali, sorry.
Capital F7.
This is capital F of 7. That will be 1 minus e to the power minus 2 times 7. What if I ask you to find the probability of x greater than 7? Knife.
Doctor, I think it will be minus e to the power minus 2x.
It's 1 minus e to the power 0 is 1, right?
No, I mean the equation. But you're right. When you cancel 2, the minus should be there, not cancelled.
Yeah, I flipped the domain.
Yes, okay.
You see it?
Yes, I see it.
Toward just the minus, I flipped the domain. Okay, Knife, go ahead and tell me what is probability of x greater than 7? Knife.
Yes, doctor.
Yes, try it.
I don't know, actually.
Ali Abdul Rauf.
It is 1 minus the probability of less than 7.
1 minus f of 7. So that will be e to the power minus 2 times 7. What if I ask you find the probability of x between 5 and 7? Ali Al Hassan.
Capital F of 7 minus capital F of 5.
F of 7 minus f of 5. So that should be e to the power minus 2 times 5 minus e to the power minus 2 times 7. 1 will cancel out. These are all the possible questions I can ask regarding probability, and you can answer all of them. You can answer equal to, you can answer less than, you can answer greater than, you can answer in between, all of them using CDF. There is no need to go back to PDF. There is no need to integrate every time. Just plug in and answer. Any question at this point? I have got a question. In the previous example, I'll go back to example 1. My capital F of x was x cubed. My small f of x was 3x squared. I used this capital F of x to find the probability of x less than 0.5, and I got it 0.5 cube. I said this is capital F of 0.5, this is capital F of 0.5, and this is 0.5 cube, and this was 0.125. What if I ask you find the probability of x less than 1.5? Who can tell me? Amjad.
1.
Amjad said 1. Muhammad Faris, is it true?
We need to square it.
You need to square it or cube it?
3.375.
Capital F of 1.5, you will say it's 1.5 cube, which will be
3.375.
3.375?
Yes.
Can the probability be 3.375?
No.
What was the first lecture of this course?
Between 0 up to 1.
It's between 0 up to 1. Where is the problem? Amjad already answered it. Where is the problem?
It is greater than 1.
It is greater than 1. Why it is greater than 1?
Because we put 1.5. We should less than 1.5. No probability 1.5. X less than 1.5.
Ali Abdul Rauf.
That we should not exceed the 1, should be less than 1 at the
This
maximum.
CDF is only applicable for, look at this. This CDF is only applicable for a value of X between
0 and 1.
Between 0 and 1. Above 1, the CDF is 1. So above 1, forget about CDF. All the values of X are between 0 and 1. So the probability of any value of X less than 1.5, as Amjad said, the answer is straight away 1. Similarly, I can ask you another extreme. What is the probability of X less than minus 0.5? You will not do minus 0.5 whole cube. You will simply say 0 because X cannot be minus 0.5 or less. X is always between 0 and 1. So make sure when you're solving a question, either using the PDF or using the CDF, take care of the domain. Same is true for this one. What if I ask you the probability of X between 0.5 and 1.5? Traditionally, what will you do? You will say capital F of 1.5 minus capital F of 0.5. Yes?
Yes.
Yes. And this is where you will make mistake. You will do 1.5 cube minus 0.5 cube. This is not right. This part is not right. Capital F of 1.5 is 1. It's not 1.5 cube. So when you write capital F of X, it's better to write the domain of the variable also there. And above this domain, the probability is 1. Below this domain, the probability is 0. So capital F of X above 1 will always be 1. And below 1, it will always be 0. So you can also write capital F of X like this one. It's X cube when X is between 0 and 1. And above 1, it is 1. And below 1, it is 0. Below 0, it is 0. Below 0, there is no probability. Above 1, there is all probability. And in between 0 and 1, the probability is X cube. That's what capital F of X is saying. So you should write this one as the correct way of writing is 1 minus 0.5 cube, not 1.5 cube minus 0.5 cube. These are all the possible mistakes I usually see from time to time in exam. So the point is to avoid all these mistakes and take care of the domain for every question. And there was a question from someone that can I avoid the PDF? No, you cannot avoid the PDF. You have to know both ways, because I may give you PDF in the question and I may give you CDF in the question. So it's not sensible to go back to PDF and then integrate it again. It's better to plug in the values straight away. Any question at this point? Okay, I have finished the class time now. If you have any question regarding the continuous random variable, the general case, you can raise your hand, you can ask the questions, and if you don't have a question, you can leave the session now.